Okay, welcome Year 11s to this next video. In this one, what I'm going to talk about is a couple of special cases of straight lines, and that is looking at lines that are parallel or that are perpendicular. Now, there's something that we need to look at in terms of the gradients of these lines, and we're going to start off first with parallel lines. Now, considering that we know that the gradient is a measure, well, it's a measure of the slope or the steepness of a line, if you've got two lines that are parallel, effectively they are the same steepness, so they have the same gradient. So we can write that in here. Okay, so what we'll do is we'll have a look at an example. I've got two equations written here, and you'll see that the m value in here, the coefficient of the x term, it's both 2. So these two have the same gradient. So let's have a look at what this looks like when we graph it. So 2x plus 3 and 2x minus 4. So just opened up graph, and here's our 2x plus 3 graphed. If you just press tab, you'll be able to add another graph to this. So 2x minus 4 now, and have a look. They are parallel. I might just move that label over. So you can see these two lines are never going to meet. They are parallel lines, and they have the same gradient. Now, if I did this with another one, if I added another, say, just 2x going through the origin, again, parallel to the other two, not going to touch the other two at all. So what we can do is we can add these graphs that we've got here to our sheet, which is over here. So what I want you to do is graph these two on your set of axes there so that you can see that they are in fact parallel. So parallel lines, in summary, same gradient. The rise over the run will be identical. If I have a look now at perpendicular lines, this is a little bit different. So perpendicular, if you can't remember what that means, it means we've got a 90-degree angle, or also known as a right angle, between these two lines. Now, the thing about the gradients of these two lines, if you have a look at them, if you explore them, is you find that these are what we call negative reciprocals of one another. So basically what this means is if I have a gradient of 1, or the number 1, the negative reciprocal would be negative 1 over 1, which of course we simply write as negative 1. So probably not the best example, but just say I had the number 2. The negative reciprocal of 2 would be negative 1 over 2. Like so. Let's say 5, or negative 5 for a different one. The negative reciprocal of negative 5, well, if we change the sign of 5, it's going to become positive 1 over 5. Now, the thing that you will notice about these two numbers is when you multiply them together, so when you go 1 times negative 1, or 2 times negative 1 over 2, or negative 5 times 1 over 5, what you will always get is negative 1. So one of the things that will help you is to know this here, that when you multiply the slopes together, perpendicular lines, you always get negative 1. Sometimes that's a little bit easier to remember than to remember this negative reciprocal thing. Okay, so what does this mean? Let's first plot y equals x plus 4. So if you can do that here, so our y-intercept is 4 and the gradient is 1. So every time you move across 1, you're going up 1. Therefore, our line is going to pass through these points here. So you can use a ruler with yours to make it easier. I will get a line connect those points up. And there's our y equals x plus 4. You can label it as well. Okay. What we want to do is, what would the gradient be of a line that's perpendicular to this? So, if I just show you, perpendicular means at a right angle, so it's got to look something like, I put that in there, I'll remove this in a moment, it's got to have a right angle in here. Obviously the right angle can go anywhere, but you can see that it is on each line is at a right angle to the one beside it. I'll just remove that. It's going to get a bit messy. What would the gradient be of a line that is perpendicular to this? Well, if we've got a gradient of 1, as you can see, I'll call that M1, so that's this part here. If M1 is 1, that's the gradient of our original line, when you multiply it by the line, or a line that's perpendicular, we must get -1. So what you'll be able to see here is that our second line must have a gradient of -1. Therefore, if I want to write an equation of a line that's perpendicular to this original one, so perpendicular to y equals x plus 4, the gradient simply needs to be -1. Doesn't matter what the y-intercept is, because you'll notice it just says write an equation of a line. So as long as it's got this negative gradient here, then this will suffice. So if I've got, say, that's a line that's perpendicular, I could do another one. That is also perpendicular. That one there is also perpendicular. The reason that I know it's perpendicular is the gradient of each of these is -1, and that is the negative reciprocal of +1, which was the gradient of the original. Let's plot one of these. Let's plot -x plus 1. That's going to pass through y-intercept here. Gradient is 1, or -1, sorry, so it's dropping by 1 unit every time you move across. So I'm just drawing these lines in just to make it easier for me to draw this straight line, but of course you yourselves can draw this because you've had a lot of practice by now with your sketching. And don't forget to label. And as you can see, there is right angle in here. Also in here as well. It's vertically opposite. And in the opposite too as well. So there's our perpendicular line. So remember, the gradient of the first line, the one that you're given, so that was y equals x plus 4, when you multiply it by the gradient of the perpendicular line, you must get -1. And that's going to help you solve, it's going to help you work out what the gradient is of that perpendicular line. Let's have a look at some examples now. Here we have, find the equation of a line that's parallel to this one here, and it passes through this particular point. So we are going to be able to find the equation. First of all, if it's parallel to this one here, it's got to have the same gradient. So therefore, the gradient of the line that we're trying to find, the equation of the line that we're trying to find must be -2, because it's got to be the same as this one, and as you can see, it is -2. We know it passes through this point over here, 1, 9. Therefore, if I use this rule here, the general form of a linear equation, and I substitute these values, so the value for x, the coordinate of x with the coordinate of y, and the gradient, which we discovered, or having a look at the original, we know is -2. We can now solve for C. And finally, write your equation. And that is my final answer. This line here is parallel to that original one, negative 2x minus 7. We can see it is because it's got the same gradient. But the other condition was that it needed to pass through this point over here, 9 or 1, 9. So if I put those coordinates back into this rule, so if I put 9 here and I put 1 there, this equation must work, which you can see it does because we've just solved C. So it will work. This next one here, again, we're finding the equation of a line. It's parallel to this line here that's given to you, but it passes through this particular point. So again, if it's parallel, it has the same gradient. The gradient of this line here is negative 1. Using your general form, let's substitute your x and y coordinate in. So therefore, negative 7 equals negative 1 times 1 plus c. So negative 7 is equal to negative 1 plus c. Therefore, c is equal to negative 6. Write your rule out. Y equals negative x minus 6. Notice the gradients are the same, so it is parallel, but the other condition, it's got to pass through 1, negative 7. Substitute those values back into the rule if you want to check your answer and your equation. It should work. It should be balanced. The final example here is looking at the equation of a line that is perpendicular. So this is a little bit different. First of all, let's write down the gradient of the line that's given to you. So it's perpendicular to this line here. So what is your M1 value? M1 is 2. Therefore, if M1 by M2 has to equal to negative 1 as it's perpendicular, that means 2 times M2, that's got to be equal to negative 1. Solving, we get the gradient of our line that we're trying to find must be equal to negative 1 over 2. And you'll notice that is the negative reciprocal of 2. So that's why this rule is very useful if you're not confident in negative reciprocals. Now just move that to the side. I'm going to do the rest of my workings over here. I know that the gradient is negative 1 over 2. I know it must pass through this particular point over here, 2, 5. So substitute those values in so that I can solve for C, because I need that as well to be able to write out the rule. I've got my M value, I need my C value. Solving for this one here, you can just use solve on your calculator if you want to. C is equal to 6. Therefore, our final equation must read y equals negative, it's negative 1 over 2, so that's just negative x over 2, plus 6. And that's our, oh, I haven't finished that off, have I? Plus 6. There we go. All right. Thank you very much, ladies, for listening to this video. What we need to do now is get a little bit of practice, especially with parallel lines, but yes, with perpendicular as well. Make sure that you go back and pause where you need to if you have not finished filling in the examples that I've given you here.